Okay, so we're going to have a look at a couple of stoichiometry questions from the last couple of years. Now, this last year's one, we'll start with that one. Now, when 3.17 grams of mercury thiocyanate is heated in a well-ventilated fume cupboard, it decomposes rapidly according to this equation. So this is what we're given. 2Hg by SCN, or twice, that's a solid, will produce mercuric sulfide, carbon disulfide, and carbon nitride. Okay, what mass of C3N4 is produced in this reaction? Okay, if we use 3.17 grams of the HgSCN twice, so that's how much we're using. So first thing I'm going to do is write down that equation, which is 2HgSCN twice. Gives you 2HgS plus CS2 plus C3N4. And we start with 3.17 grams of this. Okay, can you see that now? Yes, you can. Right, I'm just readjusting that. Okay, so 3.17 grams of mercuric SCN is used. This is a solid. This is a solid. This is a liquid, and this is a solid. Right then, now let's mass of this produced. We want the mass of this fella. Okay, so we'll turn this into moles by dividing it by the relative molecular mass. Now, she's giving very difficult compounds recently, so be very, very careful with your relative molecular masses. So 3.17 divided by, okay, 2, now this 2, remember, is not included, so it's just the Hg, which is 201, plus sulfur is 32, plus carbon is 12, plus nitrogen is 14, and that's all twice multiplied by 2. So this gives me 3.17. When I add all that up, I get 317, and that gives me 0.01 moles. Okay, so my equation tells me that 2 moles of this will give me 1 mole of that. So I have a reacting ratio of 2 moles of the reactant giving me 1 mole of product. So I have a 1 to a half mole. So if I had 1 mole of reactant, I'd only form a half a mole of product. So this is 0.01 moles. Will give me half the amount of that. I'm just going to get another pen. Oops, 0.01 moles will give me half of that, of course, which is 0.005 moles of this fella here. Now, the question asks me to find mass. So to convert that to mass, I'm going to multiply it, of course, by its RMM. Now, the RMM of this, that's going to be 3 12s, 3 carbons, plus 4 14s. When you add all that together, you get 92. So you're multiplying 0.005 by 92, and I get 0.46 grams. Okay, so that's the first part of the question. What mass of C3N4 is produced? Now it says all of the products of this reaction, so these products here, they're all unstable. And if you heat them in air, they'll burn or decompose according to these equations. So the HGS will turn into Hg plus SO2. The CS2 will burn in oxygen to produce carbon dioxide and sulfur dioxide. And the C3N4 will produce 3 thiocyanates and nitrogen. Okay, all of the reactions go to completion. So how many litres of oxygen gas measured at STP are required for the complete combustion of CS2? So here's the CS2. If you completely combust it, you're going to form carbon dioxide and 2 SO2s. So how many litres of oxygen measured at STP are produced? Okay, so let's follow this one through. So the second part now. That was the first bit. The second part, how many litres of oxygen gas? I'm going to take this second equation here. CS2 plus 3 O2s will give us CO2 plus 2 SO2s. I'm looking for the litres of oxygen gas. How many litres of this are required? So I want a volume in litres at STP. Okay, so what does my equation tell me? So from the equation, I know that 1 mole of CS2 requires 3 moles of oxygen. What's the question again? How many litres of oxygen gas are required for complete combustion of CS2? Okay, so 1 mole will give me 3 moles of, or requires 3 moles of oxygen. So I need to find out how many moles of CS2 are being used here. So I'm going to come over here. So, back to the original equation. So, the original equation from your equation 1. 2 moles of reactant, so 2 moles of HgSCN twice will give you 1 mole of CS2. So it's 2 to 1 ratio. I know how many moles of this. This is a 1, will give you a half a mole then. Now I have 0.01 mole, so 0.01 mole will give me 0.005 moles of that. So I have 0.005 moles of CS2. So this 0.005 moles will produce 3 times as much oxygen. So 0.005 moles of CS2 will give me 3 times as much 0.005, or require 3 times as much oxygen. So that means I'll need, when I multiply that by 3, I'll get 0.015 moles of oxygen required, or produced, needed to do this. Now it says to me what volume of oxygen, so I need to multiply that by 22.4 at STP. And when I multiply 0.015 by 22.4, I will get 0.336 litres. So that's how many litres of oxygen gas are measured at STP are required. Now, the third bit, what is the number of mercury atoms produced? Okay, let's just get rid of this page here. So the number of mercury atoms. Where the mercury atoms come from? They come from this equation here. So HgS will give you Hg. 1 mole of HgS gives you 1 mole of mercury atoms. So HgS will give you 1 mole of HgS will give you 1 mole of Hg. How many moles of HgS were used? So go back to your original equation. So 2 moles, so from equation 1, 2 moles of this produced 2 moles of HgS. So from equation 1, 2 moles of your HgSCN twice will give you 2 moles of HgS. Now, how many moles of the HgSCN did we have at the beginning anyway? We had 0.01 mole. So 1 mole will give you 1 mole. So 0.01 moles will give you 0.01 moles. So you have 0.01 moles of HgS. So this 0.01 moles of HgS will produce mercury, and it's a 1-to-1 ratio again. So 0.01 moles of HgS will give you 0.01 moles of mercury. And when you multiply, if you want to get mercury atoms, you're going to multiply by Avogadro for atoms, because the types of particles are just atoms in this particular case. So when you multiply that by 6 by 10 to the 23, you will end up with 6 by 10 to the 21 mercury atoms. Okay, that's the third one. And the fourth part said, what is the total number of moles of gas formed? Okay, so these were your 3 products, and those 3 products went on to produce SO2, CO2, SO2 again, CN and N2. Okay, right. So moles of gas, let's have a look. So 1 mole of HGS gave you 1 mole of SO2. Now, how many moles of HGS did we use? We are using 0.01 moles of HGS, so that means 0.01 mole gives you 0.01 mole of SO2. That's the first one. Now, CS2. 1 mole of CS2 will produce how much gas? Well, it will produce 1 mole of CO2 and 2 moles of SO2. So how much CS2 did we use? So let's go back up to this sheet here. Remember, the amount of CS2 used was 0.005 moles. That's how much CS2 was used. So 0.005 moles of CS2 will give you 0.005 moles of carbon dioxide and double the amount of SO2, which is 0.01. And when you add these two together, you get 0.015 moles. So 1 mole of HGS gives you that much sulfur dioxide. 0.005 moles of CS2 gives you that much gas. And finally, the third one, C3, 1 or 2 moles of C3N4 will give you how much gas? Well, it will give you 3 moles of CN twice plus nitrogen plus 1 mole of nitrogen. Okay, so how much of this did we use? Let's see. Of the C3N4, which equation had the C3N4 in it now? Let me just see. That was... Do we know how much C3N4 is used? We don't yet, so we've got to find that out. Okay, so from the original equation, go back to equation number 1. So for the C3N4, 2HgSCN twice will give you 1 mole of C3N4. So initially, remember, we used 0.01 moles of this. So 1 mole will give you half a mole. So if we're only using 0.01 mole, we'll get half of that, which is 0.005 moles. So we get 0.005 moles of C3N4. Now, C3N4. So 2 moles of C3N4 will give you 3 moles of CN2 and 1 mole of N2. Okay, so 2 moles of C3N4 gives you 3 moles of CN2 and 1 mole of nitrogen. And they're all gases. So if you had 1 mole of C3N4, that would give you 3/2 moles of CN2 plus a half a mole of N2. So how much of this do we have? We've got 0.005. So 0.005 moles of C3N4 will give me 1.5 times that, which is 3/2 by 0.005 plus a half of 0.005. So this is going to be 0.0075, and this one, of course, will be 0.0025. And when I add those two together, that will give me 5 and 5 is 10, carry 1. That's going to be carry 1, 0.01 moles. Okay, so the gases. How much gas was produced? We had 0.01 mole of SO2, 0.015 moles of CO2 and SO2, and these ones here, 0.01 mole of CN2 and N2. So when I add those three together, I'm going to add 0.01, 0.015 and 0.01, and I end up with 0.035 moles altogether. Moles of gas produced. Okay.